Welcome back to the workshop for one last video on section 3.6, marginal distributions. In this example, we want to consider a joint probability density for three random variables, x, y, and z, continuous random variables. So let's take a look at this example. So this is our joint probability density for the random variables, the continuous random variables x, y, and z. So we're working within this unit cube. And we want to find the joint marginal density of x and y. So what we're saying there is we just want to remove the variable z. So we just integrate over all possible values of z, which are just from 0 to 1 in terms of the non-zero function values. So we are going to get, so for, let's see, for z values between 0 and 1, the joint marginal density is going to be given as the integral from, well, these are the only places it's non-zero, so we're just going to say from 0 to 1, we're saying that z is in here. And we're integrating, since it's in there, we'd be integrating this portion, 1/3 of 2x plus 3y plus z dz. Integrating this removes the variable z, and we can actually do this. So we're gonna go ahead and do that by hand, right? Some practice with integration. So we've got the integral 1/3 stays out front. Integral of a constant is that constant times the variable. Integral of a constant is that constant times the variable, and then 1/2 of z squared. And we're integrating from 0 to 1. Of course, when you plug in 0, it's just 0. So we just have to worry about the evaluation at 1. So this is 1/3 times, let's see, 2x times 1, which is just 2x, 3y times 1, which is just 3y, and then 1/2 of 1 squared, which is just 1/2. So that's the function of our, the value, that's the portion, the function portion of our joint marginal density for z between, well, not z between, we're looking at all possible values of z. But when we integrate this portion over all possible values of z, that's what we get. So g of x, y is, let's see here, we've got 1/3 times 2x plus 3y plus 1/2. We've got x values between 0 and 1 and y values between 0 and 1. And of course, we integrated it over the z values so that we didn't have to worry about that. And then we should, of course, integrate the second portion over all possible z values for that portion, which is everything below 0 and above 1. But the integral of 0 is 0, so it's still just 0 otherwise. So that gives us the joint marginal density of x and y. Now, if I wanted to find the marginal density of x, I would simply integrate this again with respect to y over all possible values of y to get the joint. Sorry, no longer joint. It would be just the marginal density of x. Okay, and that's it. So yay, short video on that one. Thank you for your time and attention on this section. I'll see you guys again soon back here in the workshop. Have a great day.